Hi guys, welcome back to our digital VLSA channel. Hope you are all good. Previously, we have discussed about D-Latch functionality and timing diagram. We have seen its functionality based on truth table. So let us write Verilog code and verify its functionality again. So first of all, we will write design code. So module, I'm naming it as D-Latch. What are the inputs for D? Enable comma D, right? D means data here. I mean, in D-Latch, D means data. En comma D comma. What are the outputs? Q comma Q bar. Always Q bar is complementary, so I'm not going to write that. And we need to declare which are inputs or which are outputs. Input wire enable comma D and output Q. Okay. Now, as we know, what's the functionality of D-Latch? If enable is high, it will the output is same as input, whereas if enable is low, what will happen if enable is low? The output will hold its previous output value. Okay, that's the functionality of D-Latch. So that the same thing I am going to implement here. Always at the rate of star. At star means any change in input value. If any change in input value occurs, it will go inside this always block. Or you can mention en comma d also here. Okay. Always at means at any change in enable or d. Begin if enable means enable equal to 1, what should be the output? Q less than or equal to d. This should be the output. Else Q is less than or equal to Q. Q holds its previous value. Okay, I am using here non-blocking assignments because I am writing it in inside of procedural block. Here always at the rate of or always at is procedural block. Okay, so definitely you need to use non-blocking statements. And also, if you use non-blocking statements for the outputs, you need to declare it as registers. Okay, then end module. So that's it, our design code. It is very simple. Now we will write the test bench. Module TB, and what are the inputs? Enable comma D, and we declare it as registers. And wire is for output, that is Q. And we need to instantiate that. So D-Latch dut enable comma D comma Q. So then we will write it in initial begin. Suppose let us try by keeping enable as 1 and D as 0 and giving delay, moreover dollar display statement. I'm copying the same and then I'm going to change the input values. Let us give here D as 1. Let us give here enable as 0. Here also enable as 0 and D as 1. Let it be here and here D as no. Let us give D1 and enable 0. So that's it, our test bench code. 1 second. Yeah, I need to I need to display the statements as well as I need to look at in the graph in the waveform, as we saw in timing diagram in the previous class. When we were discussing about D-Latch, the same diagram should be visible in this EDA playground also. So for that, you need to write some statements to display waveform initial begin. So $dump file for EDA playground, you need to use this dump.vcd. Definitely you need to use this, and $dump values. That's it. End, and then end module, and then you need to select simulator, and you need to tick this open EP wave after run. Okay, let me save this and then run. Okay, here it is error. It should not be, the semicolon should not be here. Again it is showing as error. Yes, here also the semicolon should not be. Yes, before looking this, we will see the outputs here whether it is correct or not. Okay, enable is 1, D 0. What should be our output? Q also should be 0. Enable 1, D 1. Q should be equal to D, so it came as 1. Enable 0, D 0. Irrespective of input, Q followed the previous output here. The same thing. When even though D is 1, Q followed the previous output only. And enable 1, D 0, Q followed the input. Enable 0, D 1, Q followed the previous output. The same thing you can observe here. Okay. Now let us understand the waveform of the latch, and if you get any confusion regarding its functionality, I will suggest you to go and check my D-Latch video. I will provide the link in description. Please go and check it out. And yes, we will see its functionality now through waveform. See, at time 0, when D is 0 and E is 1, what should be the Q? It should be same as D, because enable is high here. So Q is 0. And also when enable is 1 and D is 1, Q is also 1 because it follows the input. And when enable is 0, D is 0, enable followed or holds its previous value, right? It remains as it is, it remained in 1 only. And also when enable still, even though the value of D is 1, the enable remained or hold its previous value, that is 1 here. And when enable becomes high, DQ output follows the input. So this is how you need to observe the waveform. And see, here at time 0 I gave one input and output also I need to get. So at time 0 this occurs, enable equal to 1, D equal to 0, T equal to 0, and Q also provides at time 0 only. Okay, and then enable 1, D equal to 1 when I gave after 5 nanoseconds. Again, enable 0, D 0 when I gave after 5 nanoseconds. You can clearly observe it in the waveform. See, the next input when it came after 5 nanoseconds, you can see here 5 nanoseconds, and then the next one is at 10 nanoseconds. So observing like this is very important. You need to get thorough how to look the waveform and how to understand it. But that's it, guys. Thank you so much. If you like this video, please share and subscribe to our digital VLSA channel. And also, if you have any doubts, let me know in the comment section. Thank you so much. Bye.